Okay, this is a run through of the Maths Methods Written Exam 1 from 2012. I'll walk you through my work solutions. There's a couple of mistakes that I'll point them out along the way. So here we go. Question 1. Question 1 is a simple chain rule question. We've got x squared minus 5x all to the power of 4. Take the 4 out the front. Diff what's in the middle, you get 2x minus 5, and we have x squared minus 5x to the power of 3. So there you have it, 1 mark. You didn't need to write 8x minus 20, but you could have if you wanted. So I wouldn't expand it any further than that. There's no need. Next question, x on sine x. We want to find f dash of pi on 2. Differentiate it using the sine rule, you get sine x minus x cos x over sine squared of x. You sub in pi on 2, we get 1 minus 0 and 1, which is 1. Technically, I should have written f dash of pi on 2 here. This working doesn't really follow on. This is not equal to this unless you show that we're actually subbing in pi on 2. So I might have lost a mark there. Question 2, find an antiderivative. This question was done really badly. Might have been easier to write it as 2x minus 1 to the negative 3. Negative 3 will go up to negative 2, so we need to take out a negative 1 on 2 out the front, which you'll see here's my first mistake. And then 2x, we need another half out the front to allow for that. So this really should have been, one of these halves should have been a negative half, so it should have been negative 1 on 4, 2x minus 1 squared. If you weren't sure with this one, you can always just differentiate it again and make sure you get the correct, get what you started with. So I'm not sure why so many people got that wrong. A lot of people have a log in there somewhere. That would only be the case if this was 2x minus 1 to the power of 1. No logs. Alright, question 3. h of x equals 2x cubed plus 1. Find the rule for the inverse. A lot of people just write swap x and y. Y hasn't actually been defined, so you need to write let h of x equal y and then swap x and y. Solve for y, you get the cube root of x plus x minus 1 on 2. Make sure your cube root covers the whole fraction. And then write h negative 1 of x equals that. Alright, make sure you answer the original question. Moving on, probability section. To find the expectation of x, we just need to multiply all of these together. We get a mark for setting that up, and then a mark for the answer of 1.5. Second question, could have done this in reading time. Probability that Daniel receives 1 telephone call on each of the 3 days would be 0.2 times 0.2 times 0.2, which is 0.008. Okay, now this question, most people got it wrong because they didn't realize this was a conditional probability question. What it's asking for is the probability that Daniel receives a total of 4 calls, given that he gets any calls at all. So we could set it up like this. The probability that Daniel's going to receive any calls at all on each of the 2 days would be, the probability that he receives any calls at all is going to be 0.8, because that's a probability that he gets 1 or 2 or 3, which is 0.8. So 0.8 times 0.8 is 0.64, which is where the bottom comes from. The top, these are the 3 different ways that he can get exactly 4 calls. You can get 1 on Monday and 3 on Tuesday, or 3 and then 1, or 2 and 2. If we find those 3 probabilities, add them together, I get 0.29. So my answer is 0.29 over 0.64, which is 29 over 64. Make sure that fraction can't be simplified any further, because 29 is a prime number, it can't. However, if that could have been simplified, you would have lost a mark if you didn't do so. Alright, question 5, we have f of x equals negative mod of x minus 3 plus 2. A lot of people struggled with graphing this. Worst case scenario, we're only graphing from 0 to 5, so you could have just subbed in 0, 1, 2, 3, 4 and 5 into this, and then found your 5 coordinates, plotted them, joined it up. Make sure you include all of the intercepts and the endpoints. So a lot of people missed 1, 0. Okay, moving on. The coordinates are the image of the point 3,2 under a reflection in the x-axis, followed by a translation of 5 units in the positive direction of the x-axis. Reflection in the x-axis makes the y value negative, and add 5 to the x-coordinate, we get 8, negative 2. Now we want to do exactly the same thing, the same sequence of transformations to the function itself. So the equation of the function was negative mod of x minus 3 plus 2. If I reflect that in the x-axis, it just becomes negative f of x. And if I have a translation of 5 units in the x-axis, then it's going to be negative f of x minus 5. I think the easiest way to do this is using this function notation, because then all you need to do is sub that in, and you'll end up with mod of x minus 8 minus 2. I also might have used mapping or something like that. I think this is the easiest way. Question 6, we have the graphs of y equals cos x and y equals a sine x. They intersect when x equals pi on 3, so find the value of a. So we set the two equal to each other. What I've done here is divided both sides by cos of x, which gives me sine of x over cos of x, which is tan of x. And that equals 1 on a if we switch things around a little bit. Tan of pi on 3 is root 3, so a equals 1 on root 3. Now, you could have just subbed in pi on 3 and pi on 3 into here. You would have gotten the same answer. However, if we change it to tan, it makes part B a little bit easier. So we want to find the other point of intersection of the two graphs, and that's just going to be the other point where tan of pi on 3 is the same thing, which is 4 pi on 3. Tan of pi on 3 is the same as tan of 4 pi on 3, first quadrant, third quadrant, so the answer is just 4 pi on 3. Okay, this one here should have been an easy 3 marks. I would start by taking the 2 up here, which gives me log of x plus 2 all squared. Take the minus log of x to the other side, so you get log of 2x plus 1 plus log of x, and if you put those two together, you get 2x squared plus x. Then you can drop your logs and expand this, so you get x squared plus 4x plus 4. Take all of that to the other side, we get 0 equals x squared minus 3x minus 4. Factorize and solve, we get x equals negative 1 or x equals 4. X has to be greater than 0, so we'll reject that solution, and therefore the answer is x equals 4. Okay, question 8. So we have a random variable with a mean of 100 and standard deviation of 4. It's normally distributed. So we can use the symmetry of the normal distribution to answer this one. Anything using z-scores was a bit of a false start, wouldn't have helped you. So you might want to start by drawing a diagram. Here's a normal distribution, mean of 100, here's 106, and here's 94. Now, first thing you needed to recognize was that 106 and 94 are the same distance away from the mean, which means that we can use some symmetry here. It means that this area under here, the area that from 106, below 106, is going to be the same as the area, the probability that x is greater than 94. So the probability that x is less than 106 is the same as the probability that x is greater than 94, which is q. The probability that x is greater than 100 is 0.5, because 100 is the mean, it's right in the middle. So therefore this area in here from 94 to 100, if from here to here is q and from here to here is 0.5, then the shaded area is going to be q minus 0.5, which is the probability between 94 and 100. Okay, for part B, we've got a PDF given by x plus 1 on 12 from 0 to 4. We want to find the value of b such that the probability of x being less than or equal to b is 5 on 8. So we start by setting this up. I'd take the 1 on 12 out the front straight away, which gives me the integral between 0 and b of x plus 1, don't forget your dx, is equal to 5 on 8. Then you can actually take, well, if we antiderive x plus 1, we get a half x squared plus x. We want to sub in 0 and b and find that. In the meantime, we can actually take the 1 on 12 to the other side, which gives me 60 on 8. And if I sub in b, I get half b squared plus b. If you sub in 0, it's just all 0. So I'm just left with a half b squared plus b equals 60 on 8. What you had to do then, you could have used the quadratic formula or something like that. What you could have done is recognize that if I double this whole thing, I get b squared plus 2b equals 120 on 8. And 120 on 8 is 15. So if we take that to the other side, we get b squared plus 2b minus 15 equals 0. Then we can factorize and solve. So you get b equals negative 5 or b equals 3. Now b has to be between 0 and 4 because x has to be between 0 and 4, as given in the question. So therefore b is equal to 3. Okay, question 9, simple product rule question, x sine of x. If we differentiate that, we get x cos of x plus sine of x. Look up the product rule if you're not sure what to do there. For part B, we need to use the result of A to find the value of that integral. So what we do is we start by basically writing the answer to part A, which in reverse. So the integral of x cos of x plus sine of x is equal to x sine of x, which means what we want to do is we want to find what the antiderivative of x cos of x is. We don't want x cos of x plus sine of x. So what we do is we break this up to the integral of x cos x plus the integral of sine x and take that to the other side, which is what this line is here. And if you integrate sine x, you get negative cos of x, and that negative cos of x will become plus cos of x. So the antiderivative of x cos of x is actually x sine of x plus cos of x. Once you have that, we can find this here. All we need to do then is write this out again and sub in pi on 2 and pi on 6. If we do all of that and simplify, we'll end up with 5 pi on 12 minus root 3 on 2. The answer has to be in the form of a pi plus b, which we've got here. So a would be 5 on 12 and b would be negative root 3 on 2. Okay, last question. So we have the function e to the negative mx plus 3x. So we need to find, in terms of m, the x-coordinate of the stationary point. So we need to differentiate and set equal to 0. So f dash of x is equal to negative m e to the negative mx plus 3. And then we need to set that equal to 0. Now you'll see I've made a mistake here. I have left off the plus 3. So whilst I've got the correct answer, it comes from incorrect working. So I probably would have gotten 0 for this question, which sucks. Anyway, so what I should have had was negative 3 equals negative m e to the negative mx. If we divide by negative m, we get positive 3 on m equals e to the negative mx. Take the log of both sides. Take the negative mx out to the front. Log e just becomes 1. Then if we divide by negative m, we get x is equal to negative 1 on m log e of 3 on m. Now we could actually rewrite that as positive 1 on m log of e to the m minus 3. And that's if we're taking this negative and we're doing 3 on m to the power of negative 1, which is m on 3. And the reason we might want to do that is because it might make the next question a little bit easier. So we want to state the values of m such that the x-coordinate of the stationary point is a positive number. Might be a good idea to sketch the graph. So 1 on m log e of m on 3 would just look something like this. So a log graph looks like that. And the x-intercept here is going to be 3, because log of 3 on 3 is log of 1, which is 0, which gives you your x-intercept. So for m to be a positive number, therefore, it needs to be greater than 3. For the x-coordinate to be a positive number, m needs to be greater than 3. Okay, so final question. For a particular value of m, the tangent at x equals negative 6 passes through the origin. Find this value of m. So what I've done, I've started here by finding the y-coordinate of the function at negative 6, which is e to the 6m minus 18. So I've subbed in negative 6 into the function, and I've subbed in negative 6 into the derivative function as well, which gives me negative m e to the 6m plus 3. So the equation of the tangent is y equals ax plus b, where a is the gradient and b is the y-intercept. Now because the tangent goes through 0, 0, b is 0, and a is the gradient, which is negative m e to the 6m plus 3, which I found up here. So therefore my tangent equation is this, and I know that the tangent also goes through the point negative 6e to the 6m minus 18. So if I sub that in, I can actually end up solving for m. So I'm about to run out of time. I won't go through each of these lines, but I end up with e to the 6m equals 6m e to the 6m. So therefore m is equal to 1 on 6. And that's the end of the exam.